Are you guys able to see my screen?
Yes.
Cool. All right. So. All right, so as you guys probably all know, this is the Intro to Java programming class. Today we'll be going over the basics of programming in Java, so using motors, servos, continuous rotation servos, touch sensors, moving your motors with encoder base that are built into the motors, and how to use methods and classes to simplify your programming. I will be doing this in Android Studio. This will work in on Java as well. So let's just get into it. I'm going to create a new program here. Just call it FTC Kickoff. You can name it whatever you want. It usually helps to name it like with the type of like what your program is for, just for ease of finding it. And first thing we want to do to actually make it like have the proper elements of the FTC program is we want to do an extends op mode up here. This and then import it into the code. So this basically gives you the set of tools inside the program to be able to program an FTC robot. This is from first, so it's the official way to program a robot. So first things we're going to go over like basic variable values. So there's integers, which are whole numbers, negative infinity to positive infinity, but they have to be whole numbers. You have a double, which is a negative to positive, but it can be any decimal in between. You have a Boolean, which is a true or false statement. So it's like a flag on or off, and you can either set it to yes or no. And my bad, true or false. And then we have your strings, which are character or like sentence based. So whenever you actually have them, my bad, I put an S in that. Why does that S keep appearing? You do quotation marks and then you put in your value. So it can be anything with spaces, multiple characters, plus signs, exclamation marks, underscores, whatever. And then you end it off. And then you have a character, which is just one singular character. So like A, and then you use single quotes instead of like that. To create motor variables and servo variables, all you have to do is create, give the name of a DC motor. So you do a DC motor, and then this, you have to import the DC motor class, and then you give your motor a name. So if this was one of your wheels, you can name it left wheel or right wheel. I'm going to make 2 of these for a 2-wheel drive. To create servos, it's basically the same process. Just do servo with capital S, import it, and then you do give it a name. So I'm going to just call it back servo. And then touch sensors are really are the same as that. So you do a touch sensor and name it like touch or something. Once you have these are your basic variables to set up. Now we're going to actually set up the structure of the op mode. So this is whenever you activate certain parts on the FTC phone, whenever you press play, it'll run a certain section and then it'll loop and stuff. So the first one is initialize. So we're going to do @override, and then we want to do a public void and init. And this is what we're using is what's called as an iterative op mode. There's a linear op mode that uses a different style of setting up the init, start, loop, and stop. So whenever you get the public void init in, we're just going to do an override after that, and then we're going to do public void start, and then an override public void loop, and then finally and whenever you are programming, you don't have to have all of these in it. You can just choose the certain ones you want. You'll usually always have an init, and whether you're doing autonomous or teleop, you will have either a start or a loop, or you could have both. Stop is just to make sure whenever you press a stop, it goes through, and then make sure you stop everything so it doesn't happen to mess anything up. So in the init, we actually want to, our DC motor values right now are just empty and blank. They have the characteristics, but they're not actually assigned to a motor on the robot. So to be able to assign them to a motor, you want to give the variable name equals hardware map. So this is basically accessing the configuration that you would do on your phone to set up your robot. And then you want to give it DC motor with a lowercase d this time, and then .get parentheses, and then you do a quotation mark. This is where you enter your motor name. So let's say that's left wheel, and then you do the same thing with your right wheel. Now, doing it with the motor is really close to the same thing as the, actually, my bad. This setting up the servo is the same thing as setting up the motors. You just change one word in there from DC motor to servo. So you do the name of your servo. You set that equal to hardware map .servo .get, and then you give it your servo name. And then after that, if we're doing the touch sensor, same thing, except you do touch sensor capital lowercase t capital S .get, and then input your device name. So now these variables right here are actually related to your motors, servos, and sensors on the robot. So to actually get them to move, what you want to do is come down in either the start or the loop block. And then we're just going to set our motors to equal power. So we're just going to do a left wheel. And then you do set power to actually set it to move. And then you can do anywhere from a range of -1 to 1. So and this applies different powers to go at different speeds, but at the cost of less power, you also get less torque. So it's what you want to choose for it, basically. So I'm just going to set it to 1, and then right wheel set power, and then also set that to 1. So right now, both the left wheel and right wheel are going forwards in perspective of the motors. If you actually look at the robot and you have motors facing opposite directions out from each other, their positive direction will actually be reversed. So usually on a robot, on the right side, positive is forwards, and on the left side, positive is backwards. To be able to change this, you can go into your init and actually do a left wheel set direction, and then you can tell it to go in reverse. This flips the positive and negative sides on your motor, and also on the encoder values for it. To set a servo, it'll be back servo dot set power, or no, set position, my bad. And then you can go anywhere from a range of 0 to 1 on this one. You can't do -1 because servos are a set range and not a power. So if you want it to go in the general mode, we can go 0.5. To do a detection on the touch sensor, what you want to do is create an if loop. So to do or an if statement. To do an if statement, it's just if, and then you do your parentheses and enter the thing you want to check. So in this case, it's whether the touch sensor is being pressed. So so you want to do a touch equals. So to do this, what you want to do is a touch equals no, not equals, is dot is pressed, and then this will check to see if it's the touch sensor is pressed. If it is, you can do this, or you can have your else loop, and if it's not pressed, you go through this. To display information on the phone, you can actually do a telemetry dot add data, and then you give it a value for the caption. So this one's going to be is pressed. And then you can actually give it either another string value to say either yes, or you can output your touch value into it. And then to set this to display on the phone, all you have to do is do a telemetry dot update. So now that's your left wheel motors, servos, and touch sensors. To set your motors to gamepad value, so if you want to drive and teleop, you're going to want to do it in the loop so it continuously sets power to it, and use a controller variable and set your -1 to +1. So you do the dot set power, but instead of integer, you give it gamepad 1 or 2, depending on which one's driving the motor, and then you do a left stick Y. And if you you can do the same thing with the other one. If you want it arcade drive, if you want it tank drive, you just set it to right stick Y instead of left stick Y. And then you can do plus gamepad 1 dot right stick X, or you can change that to left stick X for your turning as well. So now we can get in, let's get into encoders. So to be able to use encoders, you need to actually tell the program to use encoders. So you want to do your left wheel dot set, and then this will be set mode this time. And then you want to do run not to position using encoder. And then after that, we can use that set mode. And then we can do a stop and reset encoder. So this tells the motor actually run using the encoder. So we can set target positions of your ticks and other things like that. And then stop and reset stops the encoder and then just sets it back to 0. So every time you run through an encoder set, it will automatically reset your encoder values so you don't continue counting up. So now we actually want to give it a set position to run to. So that's a set target position. And this is when you're going to enter your tick value, which is an integer. So a tick is basically a certain amount of rotation on your motor. Usually wherever you got your motor from, it will specify how many ticks per rotation there are on its website. So to be able to give it a set number of ticks, you just enter how many ever ticks you want to go. This number can be like all the way to 1 or up to however big you want. After that, to actually set it to go to the position, you want to do the motor name dot set mode, and then you can do a run to position. So this will set the motor to automatically go straight to the position. So all you have to do is do a dot set power, and you feed them all the same power. Like you feed the motor the same power from 0 to 1, because it will always go towards your encoder target. Even if the power level should be negative, because of your target position, all you have to put in here is a positive value. Then after that, we can wait. So this can be a while statement. If you're in a loop while programming your encoder, you can do an if and wait for it to not, for the wheels to not be busy, instead where we do here, where we wait while the motor is busy. So what busy does is it just checks to see if the motors are still counting to the encoder goal, so your target position. So as soon as it hits the target positions, the motors aren't busy anymore. So it'll go past this while loop, and then we can just set the wheel power to 0. And then just for being sure, we can go here, and then we can go ahead and do a set mode, and then we want to stop and reset encoders, just to make sure it does stop and reset encoders before the next one. If you don't want to reset an encoder, you don't have to do that, but it just makes programming with the encoders a lot easier. So now, if you had to type this out every single time you want to move, it'd get decently hectic and like hard to like go through your program. You can add comments by doing a / and then like describing what it does. You probably should do this. It looks good to the judges, and it helps you actually go through your code a lot easier. You can also do it to do, and then it will highlight it green, so then you're able to find it if you have something to change on as well. To make this simpler, so we don't have to write this the entire time, we can actually go down to the very bottom of our program and then create what's known as a method. So a method is like a variable housing different commands. So you can just say that variable name and then it'll run like whatever you want. So it can just run like a servo position, or it could run like all of this. So it's basically like a bucket for your programs that you can just be like, boom, and it runs it. So to create one, you just have to do a void and then give it a name. So we can do encoder forwards or something, and then parentheses, and then a curly bracket. In the parentheses, we're going to give it two variables to be able to use this at any specific situation. So we want a double speed, and we want an integer tip. So these will be applied inside the program to set the speed of the wheel turning to the position in the specific position you want. So you can use it anywhere in your program and multiple times in a row as well. So you basically just copy and paste this inside of it. And there's small things you need to tweak. So instead of the target position being set to 1,000, you can just set it to tick. And then your power, you can set that to speed. And then whenever you input this, input your variables into this, it will set your tick value, or it will run into what you input here. And whatever speed you put in will actually go be the speed of the wheel. To be able to use this, what you do is you come up to an early part of your program and you do an encoder forwards, or whatever you named your program, and it's just the name of it, and then you give it what it needs. So a 1, 0 through 1 value, or 0 to 1 value, yes, and then a tick value, which is I'm just going to do 1,000 again. So now you can use these however many times you want. So if you want to do a lot of things over and over again, you can just go do these, and then it allows you to simplify your program and make it a lot more understandable. Right now, you wouldn't be able to use this on any other program, just this program right here. So to fix that, we can create what's known as a class. A class basically houses all the methods you have, so you can use it on any other program you have. So to create a class, you want to create a new program, and then this, I'm just going to name it in encoder class, and then it's a new program. This time we won't actually have to do an extends op mode, since we're not actually going to be running the op mode with this. So now what we need to do is we need to outline the variables that we're actually going to be using. So the DC motors, like left wheel and right wheel. And then down here, we need to create what's known as a constructor. A constructor basically sets the variables to what they need to be. And if they need something from an outside program, you can implement it with this constructor. So to do that, we need to do a public, and then the name of the class, parentheses, some squiggly brackets. And then in here, we can ask for what we need. So we're going to need two things to set to the DC motors in here. So we need a left wheel and a right wheel. I'm setting these to LW and RW, so it doesn't, so actually setting them equal to each other works a lot easier. So if you do a left wheel equals LW and a right wheel equals RW, these will set whatever you input to these variables. So how we did the hardware map back here, you won't actually have to do this in this program. So now what we need to do to actually have this is either do a public void or a void. Public just makes it accessible to all programs. Void just has the basic properties of void. Void doesn't return anything. If you actually want a value to return, you can do a variable name, so like int, double, boolean, etc. You just need to have a return statement somewhere in there. So if you have this, you just have to do return, and then you give it a variable name that you want to return. So, and then you can use that inside of telemetry or something you want. So with the void, and then we want this to be our encoder forward. So I'm going to name it encoder class forwards. So with it, we're going to want the same exact variables as the last one, a double speed, and an integer tick. So with this, to be able to use encoders, or you want to do the copy it from over here. So you can just grab it and paste it in, and then change the values to what you need them to be. So now this is the set of instructions that you're actually able to use inside of this class. You can create multiple of these methods just by adding on over and over again. So you can have almost however many methods you want in a single class. It helps to split them out into multiple classes to actually be able to keep organized better, so you know what class is related to a part of your robot. What we usually like to do is like a drivetrain class, and then like you have your different parts of the robot, which are like for last year, our turret, arm, claw, and stuff like that. And then those just combine into a program of their own. So now to be able to use this, we actually want to add the class into this. So what we need to do is the program name. So encoder class, and then we're going to do a lowercase encoder class. This is basically setting up your class as a variable inside of this program. And then in your initialization, you actually want to do an encoder class dot equals new encoder class, and then you give it the variables it needs. So a left wheel and a right wheel. So this is feeding the variables your class needs into it. So now what you can do is come down here and then do an encoder class dot encoder class forwards, and it's the same thing. You just add the name of the variable you added up here and a dot. So this is how you call a class, and then a method inside of the class, and then you feed it the variables it needs. So one, and let's give it 1,500. So now this will move the robot, the wheel 1,500 ticks to 1,500 ticks. You can do turning with you can change where you want the ticks to be. You can make the tick negative, and you can add multiple motors inside of this. With you just do the same exact thing, but also add in your right motor into it. So it's basically the same thing, except doubled up this time instead of just single. So, and then with this, you're able to actually give it different tick values, so one negative, one positive, to make it turn in a way you want. So instead of forwards, you can name it encoder class turn or whatever method name you want to give it. So to be something you might want to actually return to the phone. So if you wanted to like get your tick values to display on the phone, you can create a method inside of this class known as like get tick values, and then what we can do is a return, and then you get the tick values of a certain wheel. So left wheel, and then this will have to return and value specific to it. So what we can do is in here create a int variable named left wheel tick, and then we can actually set left wheel tick to equal your actual encoder value. So to get that, you want to do a left wheel get current position, and then you return left wheel tick. So now in here, in your original program, you can go into your loop and then do a encoder class dot get tick values left wheel, and then actually what you want to do is a telemetry dot add data left wheel value, and then you give it your encoder class dot get tick values. So this will display your tick values of your left wheel during teleop. You can also do this during autonomous if you want to like troubleshoot things and stuff like that. Telemetry is a great way to actually figure out like where your program is getting stopped up, because you can enter like where your program is in it. So if you're having like a bug, if it's like skipping something or not going on to something, you can see where it gets stuck through telemetry by just adding a string of like so if you have like a string you want to add, you just do caption, and then you can do another quotation marks, and then you can enter another string into it. I actually didn't cover the continuous rotation servo, my bad. So to do a continuous rotation servo, it's a lot like a motor. You just call a CR servo, and then I'm just going to name it CR servo. It's really close to the rest, except you just change the variable names. And then to actually be able to use it, what you can do is do a CR servo dot set power instead of position, because it's it doesn't have any set positions. You can turn it however long you want in specific directions. So it can go from a -1 to actually, yeah, -1 to +1. So, and then with that, it will turn in that direction. So I think that's about it. If you have any questions, I can go over the virtual robot. My team was using this summer to like get people caught up and stuff. Feel free to ask.
Yeah, I mean, if there aren't any questions, Mark, why don't you go ahead and go through that?
All right, so let me switch. So this actually uses a different program than Android Studio. It's IntelliJ IDEA. So with this, you actually get a virtual robot, so you don't have a current robot actually started up with you. So you can create classes with this. It does have some limitations. Android Studio, like a real robot, wouldn't have, I found, but it's not too bad. So this is actually, I've found this from someone on YouTube. If you look up FTC virtual robot programming, it's by FTC 8397. They provide like how to install it and stuff. It's a lot like installing the FTC SDK onto Android Studio, except you just use a different SDK and program. So you can enter your values and create classes. So whenever you run it, it'll pop up like a screen of the virtual robot, and then you're able to connect a controller to it, and then actually hit start A, start B. You can use an Xbox controller, PlayStation. I think PlayStation. I haven't tried it yet. Logitech controller that you most people use during FTC. You can select your different op modes here, and then also your the bot you use. It gives you the configuration it already has preset into it. So your distance sensors, IMU, color sensors, servos, and motors, and you can change what robot you have just by changing the drag and drop. So